Now we will come on to discrimination tests. The test which define the discriminatory power within the deciles of any rating system. The first and the very basic foremost test is the use of Kolmogorov-Smirnov statistics, also popularly known as the KS statistics. It is a plot of cumulative defaults versus the cumulative non-defaults in the rating system. As you can see, the blue line is cumulative defaults. It means that the 10 bins which have total 100% of defaults, the first bin has some 27 or 28% of default capture in it, and it goes on increasing till the 100% population. The Z line corresponds to the non-defaults, which should be obviously minimum, starting from the minimum in band 1 and go up to 100% in non-defaults. So after plotting these curves, the KS statistics is the measurement, the perpendicular distance between these two lines, the point where they have the maximum distance between these two lines is the KS statistics. So if I see, okay, I will change the color to highlight this properly. Suppose this is a perpendicular distance and this is a perpendicular distance. Obviously this distance is greater than this one or this one or this one. So this is the biggest distance. As you can see, this is the KS statistics of our model, which comes at band 4. From an Excel point of view, we can see this in an Excel. Okay, now I have cumulative defaults as 26%, which I have used in this sheet. Cumulative defaults such as, say, the current bad rate that I have is 60%. Suppose in the first decile, 60% means that there are 648 default customers in a population of 1080, and this way I come down to the total bad population, which is 2491 out of these 12,000, implying a bad rate of 20.76%. Now this bad rate is for a particular decile. If I want to see how much the capture is, I will have to divide this 648 by 2491, which will give me my bad rate, 26% in the first decile. As I go down, it will increase to 43.4, which includes the addition of these two divided by these two, because I have this much of bads, and subsequently it will go to 100% as addition of all these divided by these. Just the reverse of this, if I want to calculate the good rate, if this much is the bad population, I will subtract this from the original population of 1080 to get the good population here in subsequently all bands, and I see that out of 12,000 I have 9509 good customers. I will calculate the good rate as these number of customers divided by 9509 in the same way as I calculated the bad rate, and I will have the total capture here as total good population by 9509.